By the time I end the sentence, 5 million of your cells have died. And by the end of the week, 2% of you are no longer alive. But don't worry, cell death is completely normal. For instance, the top 18 to 23 layers of your skin are dead. And the cells lining your GI tract are completely replaced in only 5 days. In fact, the mass we lose every year through cell death is equal to our own body mass. And it is even estimated that every 7 to 10 years, almost all cells of our body are completely replaced. Cell death already starts before we were born. Within the uterus, we generate about 3 times as many neurons as we end up with by the time we are born. As physician Lewis Thomas has aptly noted in his book The Fragile Species, by the time I was born, more of me had died than survived. However, despite all the regulated cell deaths, 9.6 million people die yearly because one cell in their body has decided to stop dying and instead proliferated endlessly, a disease we call cancer. When people were asked what disease they fear the most, 59% said they fear cancer more than any other disease. Cancer is not one, but many diseases, characterized by uncontrolled cell proliferation and the invasion into other tissue. The last part is significant. A mass of cells that lacks the ability to invade other tissue is called a benign tumor. However, a benign tumor has the potential to become cancerous. Now, there are about 100 types of cancer, but even within a single type of cancer, there's enormous genetic variability. As Sid Mukherjee puts it in an outstanding book, The Gene, a fundamental feature of cancer was its enormous genetic diversity. 2 specimens of breast cancer removed from 2 breasts of the same woman at the same time might have vastly different spectra of mutations and thereby behave differently, progress at different rates, and respond to different chemotherapies. Now, but what actually causes cancer? Cancer is caused by mutations in genes, which led some research to argue that cancer is merely bad luck caused by completely random mutations, while other researchers say that these mutations are caused by environmental factors, claiming that cancer is a preventable disease that requires major lifestyle changes. The truth is, as always, somewhere in the middle. Smoking and bad diet habits certainly increase the risk for certain cancers. But explaining a 5-year-old boy with lymphoma that he made the wrong lifestyle choices is simply wrong. But how do these mutations occur in the first place? There are different causes of mutations. One major cause are spontaneous mutations, caused by oxidative damage. And it is estimated that it happens about 10,000 times per cell per day. There are other ways how genes can mutate, such as mistakes during replication or mutations caused by environmental factors such as UV light or toxins. Now, thankfully, our cells are equipped with repair mechanisms, but these repair mechanisms are not perfect. Now, considering this, I think it's pretty impressive that we don't get cancer more often. And I think that one part of our body that deserves a lion's share of the credit for this is the immune system. While it is rather hard to estimate exactly how many thousands of potential cancer cells the immune system eradicates yearly, weekly, or even daily, we know that without an immune system, cancer can develop quite fast. Unfortunately, we got a first good impression about this in the 80s when the AIDS epidemic hit the US. Kaposi sarcoma is a cancer caused by a virus that contains cancer-causing genes, so-called oncogenes. The virus is quite harmless for healthy individuals. The immune system controls the virus and kills all precancerous cells. But in people with AIDS, where the immune system is severely suppressed, cancer spreads like a wildfire. On July 3, 1981, the New York Times reported a rare cancer seen in 41 homosexuals, often rapidly fatal. The immune system does not only safeguard us from developing cancer, it is also critical in fighting cancer once it has developed. Let's talk about spontaneous remission. Spontaneous remission is a phenomenon that occurs in about 1 out of 100,000 cancer patients, where the cancer, without any treatment, simply vanishes. And while we don't completely understand what is going on, we have good evidence that we have to thank the immune system for it, yet again. Already in 1918, a time where very little was known about the immune system, Dr. Rodenburg published a collection of 302 cases of spontaneous remission, and he noted that in many cases the remission was preceded by fever. The fever was usually caused by an infection or vaccination. But what is fever actually? The rise in temperature that we experience when we have an infection by viruses or bacteria is not caused by the bug itself, but the immune system is to blame for it, or rather to praise. Immune cells release inflammatory proteins called cytokines that raise our body temperature, which eventually helps to fight off the bug. By now, many studies have confirmed the link between fever and spontaneous remission. But unfortunately, in the 99.999% of cancer patients where spontaneous remission is not happening, the immune system simply can't find the cancer cell because cancer is too good at hiding. However, us being humans and some of us being really smart, we came up with a brilliant solution: CAR T cells, which stands for Chimeric Antigen Receptor T cells. The principle behind it is easy. You take out somebody's T cells, modify them genetically to express a receptor that recognizes the antigen on the surface of the cancer cell, then you make a ton of those cells outside of the body and give back the cancer-killing special agents to do the job. In his TED Talk, Professor Carl June talked about the efficiency of CAR T-cell therapy and explained that in his first trial, the engineered T-cells had dissolved up to 7.7 pounds of cancer mass in patients that were considered untreatable. And in later trials, when 30 children and adults received CAR T-cell therapy, complete remission was achieved in 27 patients. CAR T-cell therapy works better for certain cancers than for others. Unfortunately, cancer is smart. It evolves, and no two cancers behave exactly the same, which makes finding a universal cure for cancer pretty unlikely. However, in his other outstanding book, The Emperor of All Maladies, Sid Mukherjee brings examples on how far we have come in the war against cancer. Before the 21st century, having chronic myeloid leukemia was close to a death sentence. But fortunately, scientists figured out the Achilles heel of this cancer, developed a drug, and now people with the same cancer have a normal life expectancy. Except that in some cases the cancer mutates, becomes immune to the drug. But by that time, we knew enough about the cancer to develop a second drug, and we can now cure the mutation as well. We are in a tug of war with cancer. I like how Sid Mukherjee compares the war against cancer with the Red Queen's race in Lewis Carroll's Through the Looking Glass, where the Red Queen tells Alice that the world keeps shifting so quickly under her feet that she has to keep running just to keep her position. This is our predicament with cancer. We are forced to keep running merely to keep still. But we are running faster every day, thanks to the thousands of scientists and healthcare workers around the world. Thank you for watching.